Welcome to today's exploration into one of the coolest phenomena in physics, literally and figuratively. Yes, we are talking about superconductivity. This is a branch of physics. Okay, this is so special, that's why this is a special branch of physics, superconductivity. Superconductivity means here, conductors, electrical conductors. This is also electrical conductor. But in case of electrical conductors, what is known to you that there is a presence of resistance. Ohm's law. Resistance is calculated by using Ohm's law. Okay, resistance is equal to voltage divided by ampere. That is known to you. So that thing is known as resistance. But here in case of superconductivity, electrical resistance drops to absolute zero. Yes. Electrical resistance drops to absolute zero. Here electrical resistance is zero. There is no electrical resistance. That means here in case of superconductors, electricity flows flawlessly through the superconductors. Okay. So this is so interesting, no doubt. And this property of the superconductors can revolutionize technologies. In the field of quantum computing technologies, these are being used at present. And there are so many things. You can imagine designing power grids without any energy loss by using this technology or by using this property of superconductors. Okay, without any power loss, power loss occurs due to, power loss occurs means what? Energy loss occurs as heat. And that heat is produced due to the presence of electrical resistance. So if conductivity becomes zero, in that case there will be no heat production. So there will be no heat dissipation to the surrounding. So there will be no energy loss or heat loss. Energy in the form of heat. Anyway, you can design power grids without energy loss by using this property or by using this technology. Quantum computers could solve the unsolvable, and by the use of this technology, superconductivity, okay, you can achieve that thing also. You can design transportation systems which are absolutely frictionless. So many things could become possible by using this property, superconductivity. That's why this is so interesting. Okay. Anyway, so it was superconductivity. So what happens actually in case of superconductivity? There are certain materials and at extremely low temperatures. So low temperatures means what is the range? It is near the absolute zero. It is near to absolute zero. The temperatures are near to absolute zero. Such as, for example, 4 Kelvin. What is the lowest temperature? It is 0 Kelvin. So I am talking about temperature which is 4 Kelvin. So which is very near to absolute zero. So for certain materials, not for all materials, okay, certain materials are there. If you cooled those materials to absolute zero, nearly absolute zero temperature, in that case, you will notice this property, superconductivity. Those normal materials become superconductors at such a low temperature, extremely low temperature. So what happens actually, electrons flow in any conductors, and due to the flow of electrons, electricity flows. We know that thing. In physics, you might have studied that thing already. Anyway, so electrons flow, here also electron flows in case of superconductors. But here what happens, Cooper pairs are formed. In case of normal conductors, what happens during the flow of, when electrons flow through the normal conductors, scattering happens. due to the collisions with atoms, means collision of atoms with electrons or collision of electrons with atoms. Since collision occurs, that's why scattering occurs, and that's why resistance is there, resistance is present. That collision is the cause behind the resistance for normal conductors, but for superconductors, Cooper pairs are formed and there is no collision, scattering does not occur. Scattering does not occur. So there is no resistive force opposing the motion of electrons. Due to the formation of Cooper pairs, this thing happens, and formation of Cooper pair occurs due to that extremely low temperature. Okay, so this is the reason behind superconductivity. Since no resistance is there, therefore it becomes superconductor or conductor with a zero electrical resistance. Okay, there are mainly two types of superconductors. Type 1 superconductor is there, type 2 superconductors are there. Type 1 superconductors, they can be used only under low magnetic fields, and type 2 superconductors can be used under high magnetic fields, and this is preferable. Type 2 superconductors are preferable for technologies. Okay, means to develop technologies, type 2 superconductors are desirable because these are able to work under high magnetic fields. Okay, so there are mainly two types of superconductors. One more superconductor is there, that is called room temperature superconductor or high temperature superconductor. Okay, anyway, so what is the reason why scientists are working on high temperature or room temperature superconductors? Because whenever you are using superconductors in any technology, such as for example quantum computing, means quantum computers, so you need to maintain a very low temperature, extremely low temperature, since you are using superconductors, and to maintain very low temperature, the system becomes very expensive. So widespread use of that technology cannot become possible because it becomes too expensive due to what? Due to that maintenance of low temperature, very low temperature. That is a quite expensive process. Okay, so that's why scientists are working on room temperature or high temperature superconductors, so that they could use the superconductors or the property superconductivity at normal temperature. So that way, what will happen? That way, the cost of the equipment or cost of the technology will not be much higher. So in that case, widespread use of that technology would become possible. So that is the reason. So that means what is the conclusion of this discussion? So this is just superconductivity, this is just not a scientific curiosity. Technology means scientists are working on using this special property of conductors or this special property of certain materials to bring about drastic changes or to revolutionize technologies. You know, there are already so many applications. Superconductors are already being used in different technologies, such as MRI. MRI means magnetic resonance imaging, which is used in medical imaging. Okay. MRI in medical imaging, that is known to you. So in that case, superconductors are used. Again, in case of quantum computing, superconductors are used. Again, in Maglev Trains, superconductors are used. Maglev Trains means magnetic levitation trains. So many things are there where you would find the application of this superconductivity. Anyway, so this was all about it, today's exploration into the coolest phenomena in physics. Coolest phenomena, why? Because still these are being used at very low temperature, extremely low temperature. That's why I mentioned coolest phenomena. Okay. Anyway, so this was all about today's video. Thank you for watching this video.